Okay, so in this video we're going to look at orders of magnitude and we're going to look at comparing two numbers using orders of magnitude. Orders of magnitude are generally used to make, very approximate comparisons between two numbers. So if two numbers differ by one order of magnitude, one is roughly about approximately 10 times larger than the other one. So how do we go about comparing these two numbers? So we have two fairly big numbers here, one a lot bigger than the other one, and we're going to look at comparing the two numbers. How much bigger is one number than the other? So what we have to do first of all is rewrite the two numbers in scientific notation. So we're going to take this one here first of all, and I'm going to rewrite it in scientific notation. So this number here is, what you need to do to write it in scientific notation is move the decimal point from here back to here. So you rewrite this number as a number between 1 and 10. So in this case it's 3.45632. Now these two numbers are not the same. What do I need to do to this number to bring it back to this number here? I need to multiply it by 10 to the power of 1, 2, 3, 4, 5. So I multiply by 10 to the power of 5. Now these two numbers are the same. This number here, we do exactly the same thing. The decimal point is here. Bring it back to here so that we end up with a number between 1 and 10. So we get 5.671234423. Now these two numbers are completely different, of course, at this stage. So what do we need to do to this decimal point to bring it back here again? So we need to bring it up 1, 2, 3, 4, 5, 6, 7, 8 places. So we're looking at multiplying it by 10 to the power of 8. So now these two numbers are the same. So I've written this number in scientific notation, and I've written this number now in scientific notation. Now the next thing you need to do is look at this number here and this number here. We're going to round these numbers. So I'm going to take this number here first. This number here is less than 5. It's 3 point something. Okay, 3.45632. So it's less than 5. Any number is less than 5, we're just going to round to 1. So I'm going to round that down to 1. Again I get this number here is approximately equal to 1 times 10 to the power of 5. This number here is between 5 and 10. It's bigger, it's greater than 5 in other words. So I'm going to round this number up to 10. So instead of 5.671234423, I'm going to call this number 10. I'm rounding it up. So I end up with 10 by 10 to the power of 8. So this number here is equal to this number here, but this number here is approximately equal to this, and this number here is approximately equal to this one here. Now if you look at 1 is just 10 to the power of 0. Anything to the power of 0 is just 1. Now we've got 10 to the power of 5 here. So this here, 1 by 10 to the power of 5, is the same as 10 to the power of 0 times 10 to the power of 5. That then is equal to, when you multiply two powers to the same base, you add the indices. 5 plus 0 is 5, so we end up with 10 to the power of 5. On this side then, line down here, this side here we have 10, that's really 10 to the power of 1. 10 to the power of 1 times 10 to the power of 8. So again we just add the powers, because we have the same base 10 here. So 8 plus 1 is 9, so we end up with 10 to the power of 9. So this number here, 345,632, is approximately equal to 10 to the power of 5. This number here is approximately equal to 10 to the power of 9. So we want to compare these two numbers. So what we do then is we take the larger one here, in this case 10 to the power of 9. I'm going to divide it by 10 to the power of 5. When you divide two powers, you just subtract powers when you have the same base. So it's 10 to the power of 9 minus 5, which is 10 to the power of 4. So what you would say here then is that both numbers differ by 4 orders of magnitude. So both numbers differ by 4 orders of magnitude. This number here. And that's it.